Hello YouTube, this is my first video in my module on what we call exploratory data analysis, which is different from what we typically look at, which is traditional data analysis. But in traditional data analysis, we often simply look at a description of data as involving some sort of mean as its measure of where the center is, the center of the data. We find the mean or the average, and then the standard deviation, which is just a measure of spread. Well, in this video, we're going to be discussing what we call exploratory data analysis. And in exploratory data analysis, a little bit different. All we really are concerned with is where is the middle of our data set and how is it spread, of course, a lot like traditional data analysis. But instead of looking at the mean and the standard deviation, we often look at these two measures. We say we look at the median, okay, which represents the datum that is in the middle. This is the pure center of the data where it's located. And then also, instead of the standard deviation, we have the IQR, which is short for the interquartile range. Okay, so we talk about quartiles quite a bit in statistics. Interquartile range. So the range between the middle two quartiles, but this is our measure of spread. Cool, man. So we're going to be doing this exploratory data analysis, and specifically coming up with what we call a 5-number summary, and then a box and whisker plot, which is just a graph of the 5-number summary, essentially, and then interpreting that graph. So let's go and get started by defining what we mean by the 5-number summary. We say the 5-number summary is a set of 5 data, and it involves 5 values here. We say the minimum, the maximum. We might as well note those right now. So given a data set, the min and the max, but also Q1, Q2, and Q3, where we're calling Q2 the median. Okay. So when it comes to finding the 5-number summary, essentially what we're going to do is we're going to find the quartiles for the data. And when one says quartile, I hope you see this prefix here, quart, or like quarter. Basically, we're going to take the entire data set and we're going to arrange it from smallest to biggest and split it up into 4 equal size sections. So let's go ahead and get started and find our first 5-number summary. This data set right here, we see we have a stockbroker recorded the number of clients she saw each day over an 11-day period. It says the data are shown below. Find the 5-number summary for the data. So this is what we want to do here. First thing that's important to do is put this in order. Okay, so we say, well, what's our smallest datum? It looks like we have a 23 here followed by a 29. And we hop out of the 20, so we say 23, 29. Let's make our data array 30. We definitely have a 30 here. Do we have another 30? No 30. Anything else in the 30s here? We say 31, 31, and then 33 follows it. So we say 31, 33. So those are gone. Another one in the 30s here. We have a 38. So we say 38 is gone. I think we're out of the 30s now. We say, oh, actually, we have to sneak one in here. We say 27 was one of these data. So 27, I apologize for that. 27, we'll sneak her in there. Thought I saw a 20 in there. 40, so we say 40. We have 40 in here. 42, 43. So 42, 43, and then finally 51. Okay, so I just want to make sure that we have all 11 days here. We had 11 days in the original. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have all of our data and what we refer to as our data array. Okay, array just means that it's necessarily ordered now. Okay, so what we want to do is find the 5-number summary. Well, we say the 5-number summary, first of all, consists of the min and the max. Those are 2 of our values. So the nice thing about the 5-number summary is those are kind of gimmies. Now, in order to find the quartiles, what we're going to do is we're going to split this data set in half, and then we're going to split the halves in half. So in order to split it in half, what we're doing is we're searching for the median. Okay, so like, for example, count 1 in here, count 1 in here. We count 1 in here, count 1 in here. Count 1 in here, count in another one, another one, another one, and just keep counting in till you get to this middle one here. I always recommend putting a box around this. We're going to refer to this as our median. Okay, so our median, of course, 50% of our data is larger than this and 50% below it. But we're also going to call this Q2, which means it's the end of the second fourth of data or the end of the second quartile. Now, in order to find the Q1 and Q3 for our data set, to split it up into quartiles, we're actually going to take this first half of data here and we're going to split it in half. But in order to do this, let's go ahead and switch over to like maybe a green. We are going to count in from our minimum out to what we would consider to be the median. But here's the thing, you never start on the median. No, you don't start here. You always start one place inside the median. So if 33 is the median, we're going to start here on 31. We're going to count in. So we're going to say count in 1 here, count in 1 here. Count in 1 here, count in 1 here. So we say 29 in this instance. 29 would be what we call our Q1. So it's the end of the first fourth of data. We're going to do the same thing on the right side of this data set. We're going to count in from 51 and not 33, but one step inside the median at 38. So we're going to count in, we'll count in one here, count in one here, count in one here. Looks like 42 splits this side. So we say 42, and we refer to this now as Q3. So our 5-number summary, if we want to list this out, so we say our 5-number summary for this data set consists of, we say, these numbers. We can just list them. We say 23 is our minimum, 29 is our Q1, 33 is our median, 42 is our Q3, and we say 51 is our max. So again, to title these, or at least label them, we say min, Q1, Q2, Q3, and max. Okay, so there's no Q4. But when we say Q1, what we really mean is 29 is the end of the first fourth of our data. So you could look at this data set up here. We basically split it up into fourths, and we say 29 is the value you would get after counting up the first fourth of all the data that you had in your data set. Okay, so that's why we call it Q1. And Q2, being the end of the second fourth of the data, is our median. Okay, we always want to remember this. So this is how easy it is to find your 5-number summary right here. And basically it says these are the partitions for your data set. This is what splits it up into fourths. What we're interested in doing is creating what we call a box plot from this 5-number summary, and then being able to describe the data set using that. Okay, so we say a box plot, or box and whisker plot, sometimes is how you call it, is a graph of the data set obtained by drawing a horizontal line from the minimum datum to Q1. So we'd have a line here from 23 to 29. And we say also this a horizontal line from Q3 to the maximum datum. So we'd have a horizontal line from 42 out to 51 when we sketch this. And then we draw a box whose vertical sides pass through Q1 and Q3 with a vertical line passing through the median, which is Q2. So essentially we're going to put a box around these middle 3 data in here. Okay, so what this looks like in practice is this. We said, well, looking at our data set, our minimum here was 23, our maximum is 51. We could probably go from like 20, go up by 10s, 30, 40, 50, we'll call this one 60. The way this works is we're just going to put a dot above each of these numbers on the number line that we had in our 5-number summary. So for example, 23, which would be a little bit less than 25 here, we'd probably have a dot right here. So you say dot. 29 would be above, right before 30 here. We'd have a dot here. 33, so we'd say a little bit less than 35 here, so 33. 42 would be over here. And finally 51, which would be about right here. So what we said we were going to do is this. We're going to put a horizontal line from the minimum to Q1 and from Q3 out to our max, and then we'll just put vertical bars passing through Q1 and Q3 with a line passing through what we consider the median. And this is just our box plot right now. Right here. But what can we gather from this? Well, there are a few things we can gather from this. We can identify the minimum. We say, well, where's the minimum? The minimum would be right here. This is our 23. We say, well, how about the maximum? Well, the maximum is always going to be the extreme right side of this. This is our 51, but this is our min. These are our min and our max. Okay. Also, where's the median? The median will always be this middle line here. So we say this is our median, also referred to as Q2. Okay. Well, we want the IQR. Okay, so now let's review what we mean by interquartile range. The two things that we're really gathering from this graph, recall, with exploratory data analysis are where the median is and where the IQR is, or what the value of the IQR is. We can always find the median just by finding this middle line here, but the IQR, by definition, is not the total range, which would be this range right here from max to min, but the range of the box, essentially. Q3 minus Q1. So in this instance, we'd say, well, our Q3 we found down here is 42. 42 can also be seen right here. This is our 42. And we're subtracting off now Q1, which in this case right here is 29. We say 42 minus 29. Okay, so this gives us a value of 13. What this is essentially telling us is if we were to look at the range of this, not the range of the entire thing, but the range of this middle portion right here. So we say this is our IQR, and this in this instance is 13 units long. Okay, so since we're concerned with where the middle of this data is a lot of the time, and the spread of it, we could see that a very large datum like 51 could cause the range, the overall range, to be very large. We could say range would be 51 minus 23, and we say, you get quite a large value here. I think you get 28. Okay. But if you were to look at just the range of the middle box here, it gives you a better idea of how tightly packed your data is. But this is essentially how you make a box plot. Okay, so information we can obtain from this Let's start with this, the position of the median. Okay, we tend to refer to graphs as either being left skewed, right skewed, or approximately symmetric. But we say if the median is near the center of the box, then the distribution of data is nearly symmetric or approximately symmetric. So we'd say this would look like this. Anything where the median's kind of in the middle, then we'd say this is approximately symmetrical, this right here. We say, however, if the median falls to the left of the center of the box, so that would be like an example of what we have right here up on the example we did. If it falls to the left of the center of the box, the median does, we say it is positively skewed or slightly positively skewed. So this would be a slightly positively skewed box and whisker plot. Okay? And likewise, if the median falls to the right of the center of the box, so this would be something like this. Okay? We would say this would be considered what we call a negatively skewed thing. Okay? So again, we have positively skewed as the median falls well to the left of the box. That'd be a positively skewed thing. And a negatively skewed thing is when the median falls to the right. The length of the lines, however, does play a big part in this. So we say this is interesting. Lines, they kind of follow what you would think they would follow. So we say if the lines are about the same length, it's approximately symmetric. If we say if the right line is larger than the left line, the distribution is positively skewed. So here we are saying, look, if you have a situation like this, maybe your median's in the middle here, but you have a long right line, we'd say this is positively skewed because it has a long line on the right. Excuse me. Whereas if the left line is the longer of the two by far, we say we have something like this, we would refer to this as a negatively skewed thing. So you can look at it this way. Lines do not lie, so don't lie. If it's long on the right, it's positively skewed. Long on the left, negatively skewed, about balanced, it's approximately symmetrical. Position of the median misrepresents things, okay? So if the median's on the left side of the box, it's positively skewed, and if it's on the right side of the box, it's negatively skewed. So the last thing I want to do very briefly is this. Take a look at these distributions of data right here and say, okay, what can we determine from this? Are they approximately symmetric, negatively skewed, or positively skewed? So when we look at this first distribution here of data, we can see that the median, okay, falls well to the right side of this box. And the lines are about the same lengths, okay? So we say since the median was far to the right of this box, we could refer to this as being slightly negatively skewed. Okay, so remember the median is kind of backwards than what you would think it would be. If it's to the right, it's actually a negative skew. If we say letter B here, now we see that the median is sort of over here on the right, but the lines are about the same. I could see an argument for this being slightly negatively skewed, but not as much as our first distribution here, or maybe almost symmetrical. So it is somewhere between symmetric, okay, so symmetric-ish. We could also say or, we say a slight negative-ish skew. We see both here. So letter C, you notice that the median here, the median is well on the left side of the box. And actually, you can see that the line on the left is much longer than the line on the right, okay, or at least significantly longer. So this is a definite positive skew. Okay, and here's how we can tell this. We say the line on the left here, maybe it's a little bit longer than the right, which would indicate a negative skew, but because the median was so far to the left of this, we say it's definitely a positive skew here. I guess the lines are somewhat symmetrical. And then last but not least, we say this one here would be approximately symmetrical. You can see that the lines are all about the same on either end, and that the median's perfectly in the middle, somewhat, okay, approximately in the middle. So approximately symmetrical. So that's how you make a box and whisker plot. Cheers.